In this lesson, we'll be discussing heat flow through a wooden door. And the purpose of this exercise is to introduce you to the heat flow formula that's shown on your screen. We'll be using this formula to answer this question and in questions for videos to come. As you can tell, the conduction of heat depends on the temperature difference, represented as delta T, the cross-section area, represented as A thermal conductivity constant K that is specific for each material, and that all gets divided by the length of separation, L. The units for heat flow are in watts. And if you take a look to the left of this expression, you have delta Q over delta T. The units for delta Q are joules. That's the change in thermal energy. And the units for time are in seconds. So watts is the same thing as saying joules per second. So with that being said, calculate the heat flow through a wooden door of area 2.0 meters squared and thickness of 5.0 centimeters when the temperature difference is 20 Kelvin. The K for wood is 0.10 watts per meter times Kelvin. Notice that the units for the constant are in meters, whereas over here the thickness is in centimeters. So the first thing that I want to do is convert 5.0 centimeters into meters, and that's pretty easy to do. Just divide by 100. And if we do that, you get 0.050 meters. All right, we've been told the area, that's our A. We've been told the thickness, that's L, the separation in this case. And we've been told the constant K. We're good to go from here. So I have H is equal to 0.10 watts per meter times Kelvin. That's the first factor, times the area being 2.0 meters squared. And that gets multiplied to the difference in temperature being 20 Kelvin. And that gets divided by the separation being 0.050 meters. All right, let's analyze the units here. We have meters squared, and that will cancel out with this one and that one once you rearrange it. This Kelvin unit will cancel out with that one, leaving us with the only unit remaining being watts. Let's use our calculator to find out how many watts that is. Remember, watts is joules per second. So think of how much energy per unit time is moving across the store. 0.10 times 2.0 times 20 divided by 0.05 makes 80 watts. Let's write that down. 80 watts or joules per second, but you rarely write it down as joules per second. And so there you have it. Now you know how to calculate heat flow, in this case through a wooden door, but the same method can be applied to other substances.